Hello, in this video we will see the answers of GATE Aerospace 2022. So I'm going to solve all questions of GATE Aerospace except the aptitude questions. So the questions starts from question number 11. So the first question is the equation of a straight line representing the tangent to the curve y equal to x square. Y equal to x square is given and this point is given. So we have to apply the formula. So I already solved, so I just want to show you how to solve these questions so it will be easy to understand. So the question number 11 is y equal to x square is given and the slope dy by dx is equal to m, that is the slope is equal to 2x. Okay, if we differentiate the x square with respect to dx, it will get 2x, right? So the at point 1 comma 1 is, you can say, the we put the value x equal to 1 because the 1 is here, equal to 2, and then equation of tangent is y minus y1 is equal to m to x minus x1. So this is the equation of tangent. So at point 1 comma 1, that is x1 and y1, then we just apply this value in this equation, we will get finally this equation, and this is the option you can see here. Okay, C, option C. Okay, y minus 1 equal to 2 into x minus 1, right? So the next question is question number 12. This question is also from the mathematics. If the vector I plus j is rotated about positive k by 135 degree, once get. So actually the ij and k be the unit vector in the xyz direction, and if the I plus j is rotated about positive k, okay, it is rotated about positive k, so it is actually the rotational matrix. Here you can see, let's assume u equal to x plus y plus z. Okay, so according to the rotation matrix, Rx is equal to, this is the formula actually, 1 0 0 0 cos theta minus sin theta 0 sin theta cos theta for Rx. For Ry equal to this equation, and for Rz is equal to this equations. So actually this is rotation about the z axis, so we will apply this formula Rz, and this is the formula, and we multiply with, have the xyz value, so we just multiply with this two matrix. Okay, this one and this one. So here we will have, after multiplying, we will get the x cos theta minus y sin theta, x sin theta plus y cos theta, and z. And here you can see I plus j plus, because it is rotation about z axis, so here we will get the z is equal to 0 and theta equal to 135, that is given in the questions. So we just apply here theta equal to 135 and z equal to 0. Finally we will get this one. Okay, actually the cos 35 is equal to minus sin 45 and sin 135 is equal to cos 45. Okay, we convert this and we can use this to here, and the sin 45 is equal to 1 by root 2. So after putting these formulas, we will get finally Rz is equal to minus root 2 0 0. So this is I j k, that is x y z. Okay, if we compare with x, y, and z. Okay, so minus root 2 0 0. So the final answer is for Rz is equal to minus root 2I. So this is the way to solve these questions. So minus root 2I, that is D is the right answer. Okay, and then question number 13. Okay, so actually it is better to download this question paper. Okay, question 2022 aerospace engineering. I will put this all questions question paper and answer sheet solutions. Okay, in this video description, please go to the description and download from there, and then try to open first, print out these questions, and then watch this video, so it is easy to understand. Okay, so the question number 13 is, let x be a real number and I is equal to under root minus 1. That is the complex number, and then the real part of cos ix is. So how to solve these questions? Actually, we can use this I equal to minus 1, and the trigonometric function in terms of exponential function is, we have this formula, okay, sin x and cos x. Please try to remember, but this, because this formula is very important, okay, in terms of trigonometric functions and exponential functions. So I will apply this formula because the question it is given cos ix. Okay, so according to this, cos ix is equal to, just put x is equal to ix. Okay, so here e to the power I, that is given in the formula, and x is equal to ix. Again, minus I into ix divided by 2, and we just multiply I square x, so I square equal to minus 1. So here e to the power minus x plus e to the power x divided by 2. And we have one more formula for hyperbolic function in terms of exponential function. So sin hx equal to e to the power x minus e to the power minus x divided by 2. Okay, and cos hx equal to, this is the formula. So here you can see, for hyperbolic function, formula is cos hx e to the power minus e to the power x plus e to the power minus x divided by 2, and here after solving this I got cos ix equal to same, right? It means e to the power minus x plus e to the power x divided by 2 is equal to cos hx, and in option it is given, after solving you will have this kind of option, like you can see sin hx, cos hx, cos x, and sin x. So here I got cos hx, that is B is the right answer. Question number 14. The point of maximum entropy on a phenol in a temperature entropy Ts diagram represent the. So for question number 14, so this is the Ts diagram, okay, of the phenol flow, and this is the line, phenol line. Here you can see I mentioned like this is the point, okay, in this point A Ta star, okay, this is the ambient temperature Ta. Before you can see B, and after you can see, here is the line C, and actually you can see here, you will find in this point S constant, that is entropy is the constant, okay. This dotted line you can see. So okay, once you understand, once you read the Ts diagram for phenol flow, then you will understand the entropy constant. And here is the some more important line, that is the phenol line curve. This line, the phenol line above the critical temperature must be subsonic. So this is the point, and above the this, that is the point B, this line B must be subsonic. So this line is subsonic, okay, and below the critical temperature, okay, that is line C, must be supersonic, okay. So this is supersonic and this is subsonic. So the Ts diagram for phenol flow entropy formula is this one. When we differentiate with temperature, we will get some formulas where the Cp equal to gamma r by gamma minus 1, and we know the Mach number. So at state A, okay, in this point Va is equal to under root gamma r2 and C is equal to under root gamma r2, local velocity, and this is the velocity, streamline velocity and mean velocity. So at the sonic, you can say at the critical temperature, critical line, always we have the m equal to 1, okay. So the answer is m equal to 1 for these questions, because we have the at critical line at state A, okay, and at the critical line VA and CA is equal to same formula under root gamma RT, and according to this formula we will get, when we put under root gamma RT here, okay, equal to 1, that is m equal to 1. So for question number 14, okay, we will get the sonic Mach number, the point of maximum entropy, okay. So actually this is the point where is the maximum entropy. After then it, see, here is increasing and again is a maximum and this is decreasing, okay. So this is the maximum entropy, okay. So at the point of maximum entropy we will get m equal to 1. Question number 15 is, consider a two-dimensional potential flow over a cylinder. If the free stream speed is u infinity, the maximum speed on the cylinder surface is. For question number 15, from the potential flow, the velocity distribution is this one, where x by r is equal to dimensionless arc length, okay. This is the diagram. So v theta equal to v infinity sine theta of 1 plus a square by r square. This is the formula. If a is equal to r, then v theta equal to, it will become 2v infinity sine theta. And theta, for theta equal to 90 degree at maximum, it will show the maximum when theta is equal to, this theta is equal to 90 degree, okay. It means it will goes here, okay, 90 degree, that is the maximum. So we will get v theta is equal to 2v infinity, okay. That is the option C. Here you can see 2v infinity or 2u infinity, okay. So I mentioned v infinity, so option C is the right answer. In question number 16, consider a steady two-dimensional incompressible flow, and the diagram is given here, okay. The question is actually, the PQ is uniform and the speed at section RS is given by u of y equal to a naught y by h to the power n. That is this one. N is a positive integer. The value of a naught for which the flow through section PS will vanish is. The flow is moving from u infinity from here to here, okay. And if the flow will move from u infinity to u of y, okay, so at the last, okay, PS will, at the last the flow will be vanish here, okay. So to find the constant value, that is a naught, what is the value of a naught? So we can apply the Reynolds transport theorem, okay, that is rho dv plus rho of vn dA. For a study, this part will be 0, this part will become 0 and is equal to 0. We will just equate to 0 and integrate of this, okay, PQ and RS. This is integrate for PQ and integrate for RS for this formula, okay. Because according to diagram you can see this is PQ from here to here. After integration we will put 0 to h because the height is h is given here, okay. This is the h from 0 and here is h. So 0 to h, and after integration of this and after solving this we will have the a naught value, okay. We will get a naught is equal to u infinity of n plus 1 after solving this. So the answer is, you can see here, answer is B. So I'm just trying to solve these questions, and I suppose that you know very well about this. You must have the basic knowledge how to solve this kind of questions. Okay, I'm not going to solve how what is the Reynolds transport theorems, okay, and why we need for study what is the study incompressible system, okay, where we should mention zero value, one value, or anything else, okay, what is the integration, how to integrate from 0 to h, and then how to solve these questions. Okay, I suppose that, okay, I assume that you have the basic knowledge about this and you can just understand, okay, this is the way to solve. Okay, so this is the dA actually, area, dA is equal to W into dy, and W is the width. Okay, so we apply dA value, dA to W dy, okay, and then we solve these questions. Question number 17 is, consider the velocity distributions U of y shown in the figure for two adjacent fluid layer N1 L2. The viscous force exerted by L1 on L2 is, okay, actually here you can see the value of A0 for which the flow through section PS will be vanish, okay, through PS. Okay, here you can say PS will vanish, it means I have to mention equal to 0, it means 0, vanish means it becomes 0. Okay, so that's why here is 0. Okay, 0 is equal to, and this formula, after then you just apply. Question number 17, for two adjacent fluid layers L1 and L2, the viscous exerted by L1 on L2 is, L1 on L2. Actually, the friction and viscous forces always acting opposite to the force or fluid flow, that is drag. If fluid flow left to right, then viscous force will be exerted right to left. So according to this concept, we can apply here, if the fluid flowing left to right, then viscous force will be exerted right to left, opposite. So option B is correct, to the left. Okay, option B is the right option. The for two adjacent fluid layers L1 L2, the viscous force exerted by L1 on L2. Fluid is flowing from this side, okay, right to left, so the force will exerted to the left. This question number 18, the service ceiling of an airplane is the altitude. So we must know what is service ceiling, okay, and absolute ceiling. This is the graph, okay, for service ceiling and absolute ceiling. At service ceiling we have 100 feet per meter, FPM, feet per meter. Okay, RC is the rate of climb and H is the altitude. For absolute ceiling is the altitude at which power available equals power required only at a single speed, and no excess power is available at this speed. Rate of climb is 0. Okay, this is the definition for absolute ceiling. For service ceiling is the density altitude where the aircraft is still able to produce a specific rate of climb, and the specific rate of climb is 100 fpm. Okay, for piston engine and 500 fpm for jet engine. So remember this two also. Okay, for piston is 100 and for jet is 500 fpm. The service ceiling is the altitude at which the aircraft is unable to climb at a rate greater than 100 fpm. So at least it will climb at the rate of 100 fpm. This is actually it is mentioned for the for piston engines. And the cruise ceiling on the other hand is the altitude at which the maximum climb rate is 300 fpm. So the cruise ceiling, service ceiling, and absolute ceiling, there are three terms. Okay, so you must know these three terms. And here is given for service ceiling. So here you can see here is not given 500 fpm, that is for jet engine, right? But here is given for 100 fpm, so we can understand. Okay, so this is talking about the piston engine. So for a piston engine, the maximum rate of climb is 100 fpm, feet per minute. Sorry, this is fpm is feet per minute, because altitude will be in height, right, in minute, that's why. So the option is D. For question number 19, regarding the horizontal tail of the conventional airplane, which one of the following statement is true? So for question number 19, so for a stable we must have moment coefficient, pitching moment coefficient, okay, at the angle of attack must be less than 0. In trimmed flight, for a aesthetically stable cm naught, that is pitching moment coefficient as 0, angle of attack, okay, must be greater than 0. And the longitudinal static stability criteria is cm alpha less than 0 and cl alpha, lift coefficient at angle of attack, must be greater than 0, and dsm by dcl is less than 0. So these are the criteria for longitudinal static stability. Okay, these are for trimmed flight, and this is actually the option for question number 19. Here you can see in question number 19, option A is the right, because for horizontal tail conventional airplane, okay, actually the tail, horizontal tail contributes for cm alpha less than 0 for stability. Question number 20, here asking the beam with symmetrical T-shaped. Okay, this is the T-shaped here, and is subjected to pure bending. The maximum magnitude of normal stress is. So here you can see some more options. For question number 19, I mentioned like for trim point, this is the graph for pitching moment coefficient and incident alpha, incidence angle of attack. Okay, so nose up, nose down, and according to this graph you can see the line 1 shows that very stable, line 2 stable, line 3 neutral, and line 4 is unstable. Okay, so according to this graph we can also understand, okay, which line represents which one. For question number 20, we have the maximum bending stress formula is my bar divided by r. Okay, so this is the y bar, and here you can see this is the stress formula. And this is the stress diagram. Okay, so for question number 20, the maximum magnitude will be on bottom. You can see according to this graph. Okay, this is the upper side and this is the bottom side, and according to this graph you can see this is the maximum stress. Okay, maximum magnitude of this stress occurred on the bottom side, because once we take this is the y bar. Okay, so it represents on maximum stress is directly proportional to y bar. Okay, so here is the y bar, which is maximum. If you take from the here, okay, this is maximum. Here is the y bar from here also, okay, upper side. So upper side is this much only, and lower side is the bigger one, right? So in the bottom side, y bar is maximum, so maximum bending stress will occur in the bottom side. Okay, so only at the bottom fibers of the cross section. Question number 21 is a three-member truss is simply supported at Q and R and loaded at P by a horizontal force F. The force QR is, so asking force QR. Okay. So for question number 21, this is the free body diagram where I mentioned this is the force is given, PQR is given, 45-degree angle is there. So the reaction force, okay, for RQP this side, RQR this side, okay, and here you can see these are two different supports are there, you know, these supports and this is the roller supports, okay, so two different supports are there. So for these supports we have two reaction, okay, horizontal and vertical, and for these supports we have only vertical. So what I have mentioned here, vertical, and this is for horizontal and vertical. But RQR, this is the reaction from this line, okay, this force RQR. So for point P, at this point we just equate the summation of FH, horizontal force, all horizontal force is equal to 0. We will get F naught. Okay, what is F naught? This is F naught. F naught minus RPR cos 45 equal to 0. So RPI will be, when we convert to in horizontal force, we will have cos 45. Okay. So this is F or F naught is same, okay. So we have the F naught is equal to RPR cos 45. For node R, for node this R, we just add all horizontal force, we will have the RPR, this RPR cos 45 minus RQR. So this value is RPR cos 45 according to this angle, okay, and this one is RPR sin 45. So for RPR cos 45 minus RQR, this one equal to 0. So finally RQR is equal to F. So from equation 1 and 2 we can see, okay, RQR is equal to F. This is equal to equation number 1, okay, and that is RQR is equal to F or F naught. So finally we have question number 21 is asking the force in RQR. So force in RQR, this one have is equal to F, okay, this one. Next question is the closed thin walled rectangular channel shown in the figure is opened by introducing a sharp cut at the center of the bottom edge. So one is fully closed, one is the sharp cut is there, that is the open one, okay. So which statement is true? So this is some definitions, some important points are there. The shear center always falls on a cross section axis of symmetry, okay. So for closed one, this is the axis of symmetry and it will fall on this shear center at the centroid, okay, because this is closed one, and the shear center will be along this line because this is also axis of symmetry, but this is a C channel open one, but still it will be on the axis of symmetry. If the cross section contains two axes of symmetry, then the shear center is located at their intersection. That is what here is mentioned. Okay, and if it is open, then it is not important that, you know, like centroid and shear center will not coincide in the open channel. Okay, so in the closed channel, okay, the centroid, this is centroid and center of shear center will be coincides, but in open center, this is the shear center is here, centroid must be here. Okay, in this way, so it is not coincides. So according to this, we have centroids of 1 and centroids of 2 coincides. So it will coincides because it is same place, but shear center not, because for shear center in this number 1 we have shear center is here, center is also here because this is closed one, and here is shear center, centroid is here and shear center must be in this line but out of this. Okay, like this, because this is open one. So option A is the right answer. Question number 23. The region of highest static temperature in a rocket engine and the region of highest heat flux are. Here you can see the question number 23. The option is B. Okay. In a rocket engine and the region of highest heat fluxes are combustion chamber. Highest static temperature must be in the combustion chamber, and about highest heat flux we will have the nozzle throat. Okay. For question number 24, if A, B, C are three mutually perpendicular unit vectors, then A dot B cross C can take the values. So we can solve these questions as like this. We have the formula B cross C is equal to BC sin theta. Okay, unit vector n. So we applied, we will have, because this is the unit vector, so we will have 1 values and theta is equal to 90 degree, that is n. A dot n is equal to 0 or 180 degree, because n is perpendicular to the B cross C and A is also perpendicular to the B cross C, that is A is parallel to n. N and A, both of them are perpendicular to B cross C. It means A must be parallel to n. Okay, this and this one. That's why that two values are perpendicular to B cross C. So for that A dot n must be either 0 or 180, because this is a parallel. Okay, for parallel it means either 0 or 180, means same side or opposite side. You can see this is the 180 degree, right? Yeah. We can say 0 also, 0 degree or 180 degree. A dot n is equal to an cos theta, that is 1 is to 1 into 1 cos 0 or cos 80 degree. So we don't know it is 0 or 180, so we will mention both 0 or 80. For 0 we will have 1, for cos 180 we will have -1. It means here we will option B and C, that is either 1 or either -1. Question number 25. Across an oblique shock wave in calorifically perfect gas, we have the option B and D. The stagnation entropy changes and the speed of sound changes. Okay. So actually in these questions across oblique shock, okay, when the flow will go from here, that is m equal to -1, across oblique shock, what will happen? This is the before the free stream, after free stream, okay, after this oblique shock or normal shock. So there are so many properties are there. If we apply like temperature T P before the normal shock or oblique shock, okay, after that it must be changed, okay, so many values will be changed like temperature, pressure, density, entropy. So in oblique shock, okay, the stagnation entropy must be changes in this, it will be changed, okay, and the speed of sound changes, okay, velocity will be also changed here, speed of sound, okay, after the shock. So we must know the properties of normal shock and oblique shock, expansion wave, okay. If we apply something, what will happen after shock? So in these questions we have the option B and option D. NACA 2412 airfoil has, here I mentioned some concepts like NACA 2412 airfoil has a maximum camber. According to this number, it means maximum camber of 2%. This number represent located 40%, okay, so this number represent 40%, it means 0.4 chord from the leading edge with maximum thickness, and this last two numbers represents thickness, 12% of the chord maximum thickness, that is maximum camber at 40 degree 40%, and the thickness 12% maximum thickness. B and C is the right option. Question number 27. For international standard atmosphere up to 11 km, which of the following statements is true? So in these questions we have given 4 options, okay. Actually the Lapse rate is wrong. The Lapse formula is 0.0065 Kelvin per meter, okay. So this is the formula, and for question 27 we have the option A and option D is the right option, because hydraulic equation we have dP is equal to minus rho gh, okay. So according to that we have A, the hydraulic or aerostatic equation we used to find out the altitude or initial temperatures, and air is treated as perfect gas. In option B is wrong, because the Lapse rate formula is this one, and at the sea level conditions are taken as pressure is okay, density is given 300 Kelvin, we used to take 298 Kelvin, and density is given 1.2. This is correct, this one is correct, but temperature must be 298 Kelvin, not 300, so it is also wrong. So option A and D are the right options. For question number 28, okay, so if we understand the Mohr circles, we can easy to understand, okay, what should be the Mohr circles for pure bending, pure stress, because we have the formula for bending equation sigma y is equal to m by I is equal to E by R. For pure bending, it means only compressive or tensile stress, no shear stress. So sigma x equal to sigma, mention sigma y equal to 0, because of either it will be compressive or tensile. So sigma y and stress sigma z must be 0. Center we can find sigma by 2. We have the formula R is equal to under root sigma x minus sigma y by 2 square plus tau x square, tau xy square it means when we apply sigma x equal to sigma in this value and sigma y and tau x, finally we will get r is equal to sigma by 2. And same for if we apply sigma x equal to minus sigma also. So for r equal to sigma by 2 we will get this mode circle. For r equal to minus sigma by 2 we get this mode circle left side. Okay, it means either this one for r equal to minus sigma by 2 and either this one r equal to sigma by 2. Remember, it is for pure bending because there is no any mentions for stress. Okay, it is pure bending. 29 is an isotropic linear elastic material point under plane strain condition in the xy plane always obeys. So here is given plane strain condition. Okay, remember this plane strain condition. So these are some condition like for plane stress condition. So we have the plane stress condition sigma z equal to 0, tau xz equal to 0, tau yz equal to 0, gamma xz and gamma yz equal to 0. These are the conditions. Okay, for plane strain condition we have epsilon z, gamma xz, gamma yz, tau xyz and tau yz is equal to 0. Okay, this is the strain. Epsilon means strain. This is shear strength. Gamma is the shear strength. Tau is the shear stress and sigma is the stress. Okay, should I write here? This is stress sigma. This is shear stress. Okay, tau. Gamma is the shear strain. And epsilon is the strain. Okay, so these are the conditions we must understand and remember. Okay, for plane stress condition and plane strain conditions. According to that we have A, C, D. Okay, A, C and D. Here you can see the condition. 29. For question number 30, a high pressure ratio multi-stage axial compressor encounters an extreme loading mismatch during starting. Which of the following techniques can be used to alleviate this problem? Blade cooling, variable angle stator vanes, blow-off valves and multi-spool shaft. So in this problem, I mentioned only B, C and D here. Variable angle, blow-off valves and multi-spool shaft. So this is the concept from the high pressure ratio. Okay, for the compressor and the extreme loading mismatch during starting. Due to extreme loading, okay, what will happen? Where it will be the effect occurs. So most of the effects will occur during starting at the extreme loading, variable angle stators, blow-off valves and multi-spool shaft. Okay. These things is mentioned in one of the book. Okay, and that from one book you can have the answer of this. Okay, what will happen during this extreme loading. For question number 31, x equal to given y, z and theta values given. The formula for arc length of the parametric is integration of theta 1 to theta 2 dx by d theta divided by d theta and dz by d theta square. So dx by d theta, actually here you can see x is given. So dx by d theta divided d theta we just differentiate and we can mention here. Okay, dx by d theta equal to minus sin theta cos theta, and it is 1. When we square, we will get the sin square theta cos square theta plus 1. So these two values, sin square theta plus cos square theta, is equal to 1. 1 plus 1 is equal to root 2 and 0 to pi, because angle is given here, theta equal to 0 and theta equal to 2 pi. This is a straightforward question if you know the arc length formula. So after that we will have 8.9 answer. Okay, for question number 31. For question number 32, the question is, an unpowered glider is flying at a glide angle of 10 degree. Its lift to drag ratio is, the formula is lift to drag ratio is equal to 1 by 10 theta, 1 by 10 of 10 degree, L by D is equal to, okay, when we solve this one we will have the 5.67. okay, 5.67 is the answer. Question number 33. Sigma xx given, sigma yy given, tau xy is given. The normal stress sigma n on the plane inclined 45 degree. You know the formula, normal stress is equal to sigma square theta sin square theta plus 2 tau sin theta into cos theta. You just put the formula sigma x, sigma y and tau and angle. Finally we'll get normal stress 110 megapascal. In question number 32 we have the equation that is bypass ratio of 9. Hot exhaust speed is given 1.5 times that of a fan exhaust speed. The engine is operated at a fuel to air ratio of F equal to 0.03. Both the fan and the core streams have no pressure thrust. So we have to find the ratio of fan thrust to the ratio of thrust. I mean the fan thrust to the thrust. What is fan thrust? It is cooling and thrust from the core engine. That one, hot thrust and cooling thrust. So this questions from the turbofan engine. So in turbofan we have the cooling section and the hot section, that is the core sections. Okay, that is the BR is the bypass ratio. Okay, VH is velocity of the core, that is the hot, is 1.5 of the velocity of the fan. Okay, that is cooling. 1.5 of VFC, that is given in the question. Okay, has core hot exhaust speed 1.5 times that of the fan exhaust speed, and fuel ratio is given 0.03. We have the formula, thrust of the fan divided by thrust of the hot, that is the core engine, is equal to bypass ratio VFC divided by 1 plus F into VCH. The VFC divided by VCH, we will have 1.5, right, according to this, from this relations. Bypass is given, this is 1 divided by 1.5, this is actually VFC by VCH. 1 plus F is given, and finally solve, we will have the 5.8 answer. In question number 35, in a single stage turbine, the hot gases come out of the stator nozzle at a speed of 500 and angle is given 70 degree. Turbine axis shown. The design speed of the rotor blade is 250 meter per second. The rotor blade angle beta. So if you know how to draw velocity triangle from the blade system stage for stage turbines, okay, turbine blade, a compressor blade, so it is very easy to solve these questions. So according to this equation, you can see, just just this arrow here. Okay, so we have this line and this line, right? Okay, angle is given, that is total 170. Okay, total here is given 70 degree and beta is given from here. Okay, so u is given, c is given, ca, that is absolute velocity is not given, and cw var velocity, and this is the axial. Okay, so according to this triangle we have tan beta is equal to vw by c, and that is rotational velocity, that is here this part, vw whirl velocity, rotational velocity, and ca absolute velocity. So beta is equal to tan inverse of cw minus u divided by ca, that is cw is equal to c sin 70 and ca equal to c cos 70. Okay, according to this equation we can find. Okay, this angle is given, so cw. Okay, this is actually the trigonometric relations. Okay, and using this cw and ca we can find where beta is equal to tan inverse of this. Finally we will get 52 degree. Once you have cw, u value is given, and ca, just put here beta, you can find the beta. The height of a right circular cone of maximum volume that can be enclosed within a hollow sphere of radius r is. Question number 36. The height of a right circular cone of maximum volume that can be enclosed within the hollow sphere of radius r. This is the hollow sphere, and it is enclosed the right circular cone. This is height. Okay, let's suppose this is the value r and this is center, and this capital R is the radius of a sphere. So this capital R is the radius of cone. Okay, this circular cone, and a small r is the radius of this sphere. Okay, so according to this diagram we will have the AC is equal to h minus r. Okay, and we know the formula h minus r from the Pythagoras theorems. H minus r square plus capital R square equal to r square, and we have the volume of cone is equal to 1 by 3 pi r square h. We just put the r square value here. Finally we'll get the volume is equal to 1 by 3 pi, and this 2h square r minus hq. For maximum or minimum we must differentiate is equal to 0, and finally we'll get h equal to 4r by 3. To know whether at h is equal to 4r by 3 is maxima or minima, we just double differentiate and we put the value of h like 1 by 3 pi 4r 6, and h we can give 4r by 3. Okay, and when we see it is negative, that is less than 0, it is maxima. Okay, that is h equal to 4r by 3 is a maxima. So the option here you can see 4r by 3. If it would be mentioned, okay, like the volume of a cone is equal to how many times, what times of volume of a sphere. So if you solve this like this, because the volume of cone is 1 by 3 pi r square h, Okay, if we put the value of h is equal to 4r by 3 and solve, finally you will get, after solving this, you will have some constant value 8 by 27, and remaining you will see the 4 by 3 pi r q. This is actually the volume of a sphere. It means volume of cone is equal to 8 by 27 times of volume of a sphere. So this is a question for, if the right circular cone of maximum volume is enclosed in the sphere, okay, so what should be the height? And I mentioned some more questions. If the height of the cylinder of maximum, height of the cylinder of maximum volume that can be inscribed in a sphere of radius r is, so it might be the question will come like this. Okay, this is the cylinder. Okay, so this is upper part of cylinder, you can see, and it is inscribed in a sphere. Actually this is a sphere. Okay, and this is the cylinder. This part, so we will have r, this value r is equal to 2r by 3, altitude h is equal to 2r by 3, and maximum volume is equal to 4 pi rq by 3 r3. So you can find the similar question like this, and in Google you will have the complete explanation how to solve this kind of questions. Okay, the next is height of the cylinder of maximum volume that can be inscribed in a cone of height h is h by 3. Okay, cone and height is given, cone and the cylinder is given. So the h, capital H, that is this h, cylinder, height of cylinder is must be the 1/3 of height of cone. Okay, for maximum volume. For question number 37, consider a differential equation is given, boundary conditions given, the value of y at x equal to 1 by 2. This question is very easy. From the auxiliary equation we can find, okay, convert to this equation where we will find out the m equal to 1 comma 1. Complementary function cf is equal to e to the power x c1 plus c2x, because these both values are real. And once we differentiate this, we will have the e to the power x c2 plus c1 plus c2x e to the power x. We apply the boundary condition x equal to 0, y equal to 0, we will get c1 equal to 0. At x equal to 0, we will have the dx equal to 1. That is, finally c1, we put c1 equal to 0 here, then we will have the c2 equal to 1. This is the boundary condition, it is already mentioned in the questions. You can see y equal to 0 and dx equal to 1. At x equal to 1 by 2, once we put x equal to 1 by 2, we will have y equal to e to the, actually from this boundary condition and this one, we got c1 and c2 value. Once we put this c1 and c2 value in y here, we will have this equation. Now we put x equal to 1 by 2, okay, then finally we will get y equal to under root e by 2. Okay, so here option C is the right answer. Consider the partial differential equations where x, y are real. Which one of following is correct? So this is the very easy questions. Okay, only we put the answers. Okay, everything is given here. Okay, we must try to interpret and then try to find. Okay, here is given the option ax is periodic function and by is linear function. Partial differential equation is given, f value is given, and x, by are real functions. Okay, which of the following statements can be true? In this ax, bx is mentioned in these options. Ax is periodic function and by is linear. It means if we put x is periodic function and by is linear function here, and we solve and we put again this f here and we solve second, okay, derivative, so it must be equal to 0. If it is not equal to 0, it means this is wrong option. If it will valid, it means it must be equal to 0. Okay, let's try this one. Okay, so I have taken just the option number 1, that is the one is periodic, one is linear. That is, assume that x is equal to sin x and by is the linear, that is p plus qy. That is fxy equal to x into by, it is sin x into p plus qy. We put in this formula, okay, we got equal to 0. But in this part, okay, the second part we didn't get, like minus sin x plus p plus qy plus 0, that is it's not equal to 0. These are some values are there. Okay, so it is not true. Option A is not true. Actually it must be 0, but it is not 0 because we got this value. Again I have taken option C. Okay, I didn't take option B. Actually for this we have to try option A, B, C, D, and we can see which option is giving 0 value. For option C, again I assume x equal to sin x, and here is mentioned by equal to exponential, so by is exponential. I have taken e to the power y, put in this derivative, solve, finally you will get 0 value. So option C is the right option. Okay, for question number 39, a cylindrical object of diameter 900 mm is designed to move axially in air at 60 meter per second. Its drag is estimated on geometrically half-scale model in water, assuming flow similarity is given. Okay, so this is a problem from the similarity geometry, and all data are given. Okay, here I mentioned like one is prototype, one is model. In prototype this data is mentioned, and for water model this data are mentioned. Diameter is given, and here is given dm equal to dp by 2 because here is mentions its drag is estimated on geometrically half scale model in water. Okay, so prototype diameter, okay, so we according to that relation we have dm is equal to dp by 2, okay, half of the prototype. Viscosity is given for air and for water, density is given, but we don't know Vm, velocity of model, and diameter. Diameter of model is given 2280. So according to this equation, we can find the dp value, right? So from the flow similarity we have Reynolds number. We just equate the Reynolds number of prototype is equal to Reynolds number of model. We have the formula for Reynolds number. Okay, so we just equate, and 1.2 into dp into 60, and dp is equal to this one from the here. Okay, from here. Finally, we will get the Vm value. Okay, Vm is equal to 0.82 meter per second. This is the dm is the drag. So here you can see this is the drag value. Okay, this is the diameter value. The drag of model is given to 280 Newton. So what is the drag of prototype? Drag of model formula is 1 by 2 rho w vm square am into cd. Just put the model and from this equation we can find the drag coefficients. Once we have drag coefficient, just apply the formula drag for a prototype. Okay, and we will get 648 for the prototype drag. So option B 648, here is 644, it is near to 644, right? So option B is the right option. For question number 40, consider a conventional subsonic fixed wing airplane. E is the Oswald efficiency factor and AR is the aspect ratio corresponding to the minimum. Which of the following relation is true? So according to the minimum power CD by CL to the power 3 by 2, which one is the true? We have the formula for power. Power is equal to under root 2 WQ by rho infinity S. W is weight, S is the areas, rho is the density, and 1 by under root CL to the power 3 by 2 by CD. For minimum power, CL to the 3 by 2 by CD must be maximum. If it is maximum, power will be minimum. And the power is minimum when CD naught is equal to CDI by 3. This is the condition for minimum power. So we have formula CD is equal to CD naught plus CL square by pi AR, that is also equal to CD naught plus CDI. So that is drag coefficient is equal to CD naught, and we can apply this formula CD naught is equal to CDI by 3 here, and CDI is equal to 4 CDI by 3. And we know one more formula, CDI is equal to CL square by pi ER. E the Oswald constant, efficiency, aspect ratio, lift coefficient, and incident CDI is the incident drag coefficient. So CD is equal to 4 by 3, and we put this CDI is equal to CL square by pi EAR, and finally CD by CL square is equal to 4 by 3 pi EAR. Once we see check here, option B. For question number 41, we have a horizontal load F is applied at point R on a 2 members truss as shown in the figure. Both the members are prismatic with cross-sectional area A0 and made of the same material with Young's modulus. Materials are same, cross-sectional is same, okay, and Young's modulus is given, that is same. The horizontal displacement of point R applied for free body diagram. From the sine rule, we just have F divided by sine 90, FPR divided by sine 135, FQR divided by sine 135. Okay, PQR. So here is the option is given PQR. Okay, this PQR. So angle is given 45. So what should be the value of LPR? That is this one. this value. What is the length of PR? Okay, so according to this relation, trigonometric relation, we can find LPR or LQR because both of same, both side is equal to root 2L. Okay, we have the strain energy formula 1 by 2 force into displacement 1 by 2 F square into LPR divided by 2A infinity E. This is the formula. Okay, force into displacement, force into length, and once we apply this formula and put the values for LPR is equal to root 2L and FPR is equal to F by root 2 from here. Okay, then we solve for delta. Finally we'll get delta is equal to under root FL by A naught AE. Okay, so horizontal displacement of R is root 2 FL by E A naught. For question number 42, which of the following is not always true for combustion process taking place in a closed system? In closed system, total number of atoms is conserved, but molecules are not conserved, and mass is conserved. Okay, so we have the option B is correct only here. It means here you can see not always true. Okay, total number of atoms is conserved, it is right. I mean, according to this equation, okay, in the combustion process taking place in the closed system, okay, total number of atoms is conserved, total number of atoms of each element is also conserved, and total mass is conserved, but total number of molecules is not conserved. Actually molecules always change, but here is given not always, it means B is the right option. The real function y equal to sin square mod of x is, so we must understand what is continuous and differentiable at point, sharp edge, angle. Okay, so for this equation we have graph, this is the graph. Okay, and here are some important points are: any differentiable must be continuous at every point in its domain, but a continuous function need not be differentiable. Okay, means if any point it is differentiable, then it means it must be continuous. Okay, but it doesn't mean if a continuous function need not be differentiable. Okay, if there is some point continuous, it must not be differentiable, but if it is differentiable, it must be continuous. A differentiable function is smooth and doesn't contain any break, angle and cusp. Okay, it means if in this graph, if in any graph, if there is a break, angle or cusp line, cusp point, so we cannot say it is differentiable. Okay, so we have option A, continuous for all x and differentiable for all x for this graph, but at x equal to 0 and x equal to 0 we don't have continuous and differentiable as well in this point, because here is the angle making and breaking. Okay, so we will have so many points here. Question number 44, a convergent nozzle fed from a constant pressure, constant temperature reservoir is discharging air atmosphere at 1 bar with chalk flow at the exit, that is Q. Flow through the nozzle can be assumed to be isentropic if the exit area of the nozzle is increased while the reservoir parameters ambient condition remains the same. Then at a steady state, So everything is same almost, but here you can see before the area was this one, and later on it is increased to this one. Okay, this point. So what effect will happen here? There is a Chock flow condition. Okay, Pu by Pd must be greater than or equal to gamma plus 1 by 2 gamma by gamma minus 1. Okay, for isentropic we used to take gamma equal to 1.4. Pu is the upstream and Pd is the downstream pressure. The nozzle will remain chocked when exit nozzle area increase or decrease. This is the point actually. The nozzle will remain chocked. Okay, if exit area will increase or decrease. If P naught or T naught of reservoir change, then chocked flow will be changed. But here is mentioned these values are constant. It is not changing. The Mach number at section P will increase. Okay, if area will increase or decrease, okay, the Mach number in this area will be also increase. Okay, area will increase, Mach number will increase, area will decrease, Mach number will decrease, because of we have the a1 v1 equal to a2 v2 from the continuous equation. If area will increase, you can see here area will increase, a2 exit area increase, then v1 will increase. It means if v1 will increase, the Mach number will also increase. So we have A and C is the right option. In question number 45, for a conventional airplane in straight level constant velocity flight conditions, which of the following conditions possible in Euler angle and side slip angle? In on Euler angles, that is the angle of attack and side slips angle. For question number 45, we have some condition in level flight. Okay, angle of attack is equal to the pitch angle and side slip angle equal to the negative of yaw angle. So these are the two equations for level flight. Okay, and here is already mentions like a straight and level flight. Okay, so for that we just saw, okay, here you can say two conditions, alpha equal to theta and beta equal to minus xi. So pitch angle of attack equal to pitch angle, that is alpha must be equal to pitch angle. Okay, beta must be equal to negative of psi. So beta equal to 0, that's okay. So psi is equal to also 0. So according to that, A is the right option. Consider a high earth orbiting satellite of angular momentum per unit mass h and eccentricity is given E. Okay, the distance between the satellite center of mass and Earth center of mass are the two anomaly is theta and phase angle is 0. Which of the following statements are true? First one is energy is conserved, and from the trajectory equation we have this formula r equal to py 1 plus e cos theta, where p equal to h square by mu and mu is equal to gm. Finally we have this formula r is equal to h square by gm 1 plus e cos theta. So options are here, you can see the trajectory equation, this is the right equations. Energy conserved, that is H is conserved, and the sum of potential energy, kinetic energy of the satellite is also conserved. So we have B, C and D options are correct. Question number 47, we have a rocket operates at an absolute chamber pressure of 20 bar to produce thrust F1. The hot exhaust is optimally expanded to 1 bar. Using a convergent divergent nozzle with exit to throat area is given 3.5 and thrust coefficient is given 1.42. Okay, the same rocket when operated in absolute chamber pressure is 450 bar. Thrust F2 and thrust coefficient is given. Okay, so they are given two rocket. Okay, one and second rocket. Rockets is same, but operating system is little change, like chamber pressure is 50 bar. Okay, and producing thrust, once the chamber pressure some data will be changed, obviously the thrust will be changed, and thrust coefficient is CF2. Okay, so there are some condition what will happen F2 by F1 or CF2 by C1. Okay, so for these questions we have solution. We know the thrust coefficient Cf is equal to Cf naught plus A naught by AE by AT, that is already given, and P by PAC minus P by PAC, that is actually PAC is absolute chamber pressure. Okay, this is PAC. Cf naught is the optimal thrust coefficient. Initially we have given in the first rocket PAC absolute chamber pressure 20 bar and exit pressure is equal to 1 bar. Here you can see hot exhaust, that is exit pressure 1 bar, but it is given optimally expanded. So because of optimally expanded, we have PE is equal to PA. Okay, it will be equal to ambient pressure, that is 1 bar, and CF. So this one is given, so just put here. Okay, PE by PEC, that is 1 by 120 divide minus PA, that is equal to, you can see PE equal to PA, that is 1, and PAC is given 20, so you can see it is equal to 0, that is this part will be 0 for optimally expanded. Only we will have CF equal to CF naught, that is CF naught we have already mentioned 1.42 is given in the questions, 1.42. Okay, now the second rocket, ambient chamber pressure is given 50 bar, and for the CD nozzle we know that in this condition PAC2 by PE2 equal to PAC1 PE1. So from these conditions, okay, for the convergent divergent nozzle we have this condition, that is the ambient pressure, that is you can see the ambient chamber pressure. Okay, absolute chamber pressure divided by exit pressure is equal to the absolute chamber pressure divided by P1. Okay, we will find the P2 from here. We just put all values here. Okay, CF2 A by AT, P2 value, and 50 is the PAC2. Here it is. Again PE is 1 is given. Here you can see this one. Okay, that is, sorry, this is PA ambient pressure. Okay, and PE1 is given. Just put formula and we will have the CF2, this one. Now we know CF2 and CF1 value, just divide like this because in options are given. Okay, CF2 by CF1, then we will get 1.07. It is greater than 1, that is CF2 by CF1 is greater than 1. The second one is thrust force, F equal to CF P naught C AT. Okay, What is P naught C? P naught C or PAC, you can see absolute chamber, okay, absolute chamber pressure. So for this we have 82 by 81 is equal, so it will cut. Only we have CF2 by CF1, we have this already data, and PSE2 50, PSE1 20. After solving we will get 2.67, which is greater than 2.5. That is F2 by F1 is greater than 2.5. So option D and option B is the right option. For question number 48, V equal to given is a vector field. Using gauge divergence theorem, the value of outward flux of the, we have to find out outward flux of the vector. Unit radius, center at the origin. Okay. This is given. Actually, this is talking about the sphere, okay, surface of the sphere. This is given. So by parameterizing S in spherical coordinates, where S be the unit sphere centered at origin, okay, we can find, okay, x is equal to r cos theta sin phi, y equal to r sin theta sin phi, z equal to r cos phi, where r is equal to and greater than 0. These are conditions. When we convert, okay, x into spherical coordinates, so we will have these three conditions. According to Gauss divergence theorems, this is the formula. So divergence of V is equal to 3x square plus 3y square plus 3z square. What I did actually is just differentiate here this one, and then apply in outward flux in this, okay. So dV, and we put x value is equal to r cos theta here, this all value x y z put here in this formula, in this equations, and finally you will have 3 of r square dx dy dz. Now we have to convert dx by dz because this is already converted into a spherical, so this should be also convert to a spherical. So dx by dy dz equal to r square sin phi dr d theta d phi. Okay, the conversion from the rectangular to a spherical, we will have this one. So now we just put the limit 0 to pi, 0 to 2 pi, 0 to 1, and this one, okay, from here, and after solving we will get 7.5. The largest eigenvalue of the given matrix is, so A is given, and we have the trick. We know one theorem, like if A is an n by n matrix, okay, if A is n, just suppose this is A, okay, so if A is an n by n matrix with non-negative entities, and all row sums equal to the R, then the largest eigenvalue of A is R. It means if we sum of this, okay, 0 plus 1 plus 1 is equal to 2. If we sum this one, it will be 2. If we add this one, it will be 2. So all are same, okay, just change to R, okay. All row sums equal to R, all are equal 2 2 2 then the largest eigenvalue of A must be R, that is 2. According to above statements, we have answer A is, the eigenvalue is 2. Okay, here is 2 answer. Question number 40. Question number 50. The rotational velocity field in an air flow is given. A is given, B is given. Air density is given, pressure is given. Negative gravity, pressure at xy. The pressure at 0, 0 is given 100 kilopascal. Then pressure at 6 and 8. Okay, we have to find this one. From the Navier-Stokes equation, we know the formula 1 by rho delta P is equal to minus of Ax Ay. This is acceleration, this is pressure gradient, and this is density. Okay, so 1 by rho delta P, 1 by rho delta P, we can write dou P by dou x I, dou P by dou y is J, because this is the 2 unit is given, I and J. Okay, we just say 10y is equal to u, okay, and 20x equal to v. Now we can equate this is equal to this one and this one is equal to this one. We will have rho 1 by rho dou P by dou x equal to minus x and ay. X is equal to u dou u by dou x plus dou by dou. The second formula we know acceleration. Okay, in partial differentiation we have u dou u by dou x plus v dou u by dou y. Okay, just put the formula values. U is equal to 10y, we put just 10y, and dou u by dou means the differentiation of 10y. Okay, 10y is constant because I am going to differentiate with x, right? So it will be 0. Again 2x, 20x, dou y, 10y. So after differentiation of this, we will have x equal to 200x. Similarly, again for ay, okay, from this equation, from like for ax, y, ax is this formula. For ay, we have this formula u dou by dou x plus v dou v by dou y. Put the formula u and v. Which value? This one, u and v, and differentiate it. We will have 200y. Okay. Once we equate this one and this one, we have minus 200x and 200y. Integrate again both sides. From this equation, we will get p value for x, p value for y. Then total, we just add these two. We will get minus 200 by 2 rho x square plus y square plus constant c. Now we apply the boundary condition. Okay, at 0, 0 we will have c equal to 0. If we put x equal to 0, y equal to 0, it will all will be 0. So p equal to c, constant. If we apply 6, 8, x, y, density is constant, that is density is given 1 in the questions. So c is equal to 100 we just got. So finally pressure at 6, 8 is equal to 90 kilopascal. Okay, here is 90. So we can see the question number 51. Consider a circulation distribution over a finite wing given by the equation below. Okay. Gamma naught 1 minus 2y b. So 0 to b by 2 minus b by 2 to 0. Okay. If we have the wing, okay, so here is given 0 to b by 2. Okay, and again minus b by 2. If it is we can just consider 0 to b. Okay, so it means here 0 to b by 2 and minus b by 2 to 0, half of the span. Being span b is 10 meter. The maximum circulation given, density is given, free stream speed is given, the lift over the wing, we have to find the lift. So for semi span we can just consider what is given here, gamma naught 1 minus 2y by b. Just integrate it 0 to b by 2 because I am taken semi span, means half of the wing. So and apply gamma naught y, gamma naught and b value, that is given gamma naught equal to 20, gamma naught equal to 20 here, and b is given 10 mm. Okay, so finally, and 0 to b by 2, actually b is given 10, so b by 2 is 5, that's why mention the limit is 0 to 5. Gamma equal to 50 meters square per second. Now lift is equal to a small l because it is half a span, right? L is equal to rho u gamma, rho u mentioned gamma we just found 50, 4,800 Newton. For both side total lift we can find, total means twice, right? So finally answer is 9,600 Newton is the answer. For question number 52, consider a solid cylinder house inside another cylinder as shown in the figure. Okay. This is the big cylinder and this one is the small cylinder. In between here is the gap, okay, and here are some liquid fluid, and this fluid liquid viscosity is 10 to the power minus 4 Pascal second. Dimensions are there. An inner cylinder, this one is rotating at a constant angular speed of 5 radian per second, and outer is stationary. Friction at the bottom surface can be ignored. Okay, here is ignored friction. Velocity profile in the vertical gap between the cylinder can be assumed to be linear. Okay, this is linear in the vertical gap. The driving moment required for the rotating motion of the inner cylinder is, actually in these questions it is mentioned that, okay, one big cylinder is there and a small cylinder, someone is there, something is there, and here is the fluid. Okay, if it is rotating, okay, so how much moment required to rotate at the speed of 5 radian per second? Okay, what is the driving moment required? Okay, so it will rotate continue at the rate of 5 radian per second. That is the questions. So in this question a radius is given, height is given, and this is the gap, okay, between the, you can see in these questions, this is the gap 5 mm, that is I mentioned delta L. Okay, mu is given, viscosity and angular speed is given, driving moment, that is torque, is equal to force into R, and we know the force is equal to, viscous force is equal to tau into area, and tau is equal to mu into dou by dou y, area is this one, and Ri, that is the torque. Okay, this is the torque formula. So in torque, if I mention tau area, tau I mention mu dou by dou y, okay, and R is here. So finally I know torque is equal to mu, change in velocity, that is r omega is the rotational velocity, r omega, and initial is 0. Gap dy dou y, that is the gap delta L. Area is 2 pi rh, is the perimeter of that cylinder, 2 pi rh into r. Just apply all values and finally we'll get 1.26 Newton meter. Okay. Remember, this delta r is given is mm, okay, and remainings are given meter. So don't forget to make all units same, okay. Don't put 5 mm and 2 mm. Either you can change this 5 mm, okay, into meter, or you change meter into mm. Question number 53. Okay. In a converging duct, area and velocity at speed p are 1 meter square and 15 meters per second. The temperature of the fluid is 300 Kelvin. And some more data is given, specific heat gas constants are given. To ensure that the airflow remains incompressible, okay, in the duct, the minimum area required at section Q. This is section P and Q, right? Upstream and downstream. Temperature 300 because it is isothermal. From this equation, we know that APVP equal to AQVQ. APVP formula is there. Area and velocity is given. Then MQ is given 0.3. It is the minimum. Then from the Mach number equation, we know VQ is equal to MQ into under root gamma TQ. MQ and gamma to VQ find, we can find from here. Then AQ is equal to, just apply here, 15 divided by VQ. VQ we got, then we can find the AQ. Okay, and AQ is equal to 0.14 meter square. Is the answer. Okay. Question number 54. Consider a thin symmetrical airfoil at 2 degree angle of attack in a uniform flow at 50 meter per second. The pitching moment coefficient about its leading edge is. So for 54, moment coefficient is given minus CL by 4 is equal to minus 2 pi alpha equal to 4. This is the formula. Angle of attack is given 2 degree. We just change to degree to radians, 0.03491. Cm, moment coefficient equal to 2 pi. This formula we apply, and angle in radians, finally we'll get minus 0.055. In question number 55, a convergent divergent nozzle with adiabatic wall is designed for an exit Mach number of 2.3. It is discharging air to atmosphere under the condition indicated in the figure. Some terms are there. The minimum percentage change in the reservoir pressure required to eliminate the wave system at the nozzle exit under steady state is. This is actually the expansion waves. Ambient pressure is given, reservoir conditions are given. We have to find the minimum percentage change in the reservoir pressure required to eliminate wave system at the nozzle, to eliminate any waves at the nozzle exit. So what is the minimum percentage change required? Okay. To eliminate the wave system at the nozzle exit, it must follow, we have to take exit pressure is equal to ambient pressure. Okay. P naught by P is equal to, we have this formula. So find out P naught value, I found that P naught value 12.51, okay, from the exit Mach number. Exit Mach number is given 2.3. Initially the P naught is given 25, okay, we got this one, and initially it is given 25 bar. So minimum percentage change is equal to P naught initial minus P naught by P naught initial into 100%. We just take the minimum percentage change and finally we will get 49.96. This is the answer, okay. It means around 50%, you can just say 50%. So the 50% minimum percentage change required in the reservoir pressure to eliminate the all waves. Question number 56. A conventional airplane of mass is given, level turn of radius is given, speed is given, acceleration of gravity is given, acceleration due to gravity, the bank angle of the airplane is, what is the bank angle? Okay. We have formula load factor n equal to sec phi is equal to under v square by rg plus 1. Okay, we can just say phi is equal to sec inverse of v square rg by rg plus 1. V is given 100, r is given 1000 meter, and gravity is given 10. Just solve, we have the sec inverse root 2, and what is phi? Phi is the bank angle, okay. So bank angle is equal to 45 degree. This is a formula for radius, okay. When we convert this one and we take out the n value load factor, so formula will become this one, okay, under root v square by rg plus 1. Question number 57. The tip deflection and tip slope for a tip loaded cantilever of the length L are given. Okay. A cantilever PQ of rectangular cross section is subjected to transverse load F, midpoint. Two cases are considered as shown in figure, case 1 and case 2. Case 1 is free and case 2 is simply supported. The ratio of magnitude of maximum bending stress at P, this point. Case 1 to that of case 2. As we know that bending stress is equal to my by I, here you can say bending stress is directly proportional to bending moment. Sigma P at case 1 by sigma P at case 2 equal to MPI by MP2, right? Bending moment at P in case 1 minus F into L, and at case 2 is, we have to find for case 2 downward deflection due to force F, this formula, upward deflection due to reaction R, this formula, okay, for case 2, okay, because this is the roller support, so we have to find upward and downward deflection. Net deflection at tip is 0, okay, net deflection will be here is 0, here it will be no any deflection in this point. We just equal df by dr. R we will get according to this two equation once we equate R equal to 5f by 16. Then the bending moment at P in the case 2, okay, bending moment 5f by 16 into 2L minus FL. We will get this for, okay. MP1 we have, MP2 finally we got this one. So MP1 by MP2 is equal to just divided by this, and then we have 8 by 3. So 2.67 we got bending moment ratio, and according to this, we get bending stress also. Actually here in questions we have bending moment only, maximum bending stress. Okay, so we will get 2.67 is the answer. Question number 58 is a simply supported aluminum column of length 1 meter and rectangular cross section WT with T less than or equal to W subjected to axial compressive load. Young's modulus is given. Uniaxial compression is given. The value of T at which the failure load for yielding and buckling coincide is. The critical load of a simply supported beam is given pi square E by L square. Crippling stress is N by A. Okay, this is critical load and area. Critical stress is pi square A by A L square. Okay, so we just put the formula. I is WTQ by 12 and area and L square. We will get this one. We already have sigma CR. Okay, this one. Young's modulus is given. Then finally we will get T value from here, and T is 45.6. See, if you know this formula, we can just solve this formula. Okay, and we'll get the T value. Here is mentioned the value of T, that is the thickness at which the failure load for yielding and buckling coincide. Once we applied this formula, automatically it will show that it is coincide, like yielding and buckling. Okay. Question number 59 is a 0.5 meter long thin walled circular shaft of radius 2 cm is to be designed for an axial load of 7.4 kN and torque of 148 Nm. The allowable stress under an uniaxial tension is 1.100 meter Pascal. Using maximum principal stress criterion, the minimum thickness T of the shaft so it doesn't fail. It means simply asking minimum thickness. Okay, torque is given, okay, 148 Newton meter, and axial load is given 7.4 kilonewton. Where the stress is P by A, load is given, and area we can find 2 pi RT. Finally, sigma x, we will find this one, sigma y equal to 0, because only this axial load is mentioned. Tau is equal to TR by C, that is T is torque, R, J we can say polar moment of inertia, that is 2 pi RQT. Okay, so polar moment of inertia is changed according to their shape. Okay, actually according for this shape, thin walled circular shaft, polar moment of inertia is 2 pi RQT. Maximum principal stress is formula is sigma 1 2 sigma x plus sigma y 2. Okay, once we put this formula, sigma x, sigma y and tau, sigma y and tau, and sigma x, okay, so we will get finally this. After solving, we will get finally T value, because here is you can see only unknown T is there. Sigma 1 is given 100 already is given, right? Here you can see Question number 60 is a 10 kilometer axial load is applied eccentrically on a road of a square cross section. The strains measured by a two strain gauges. Here E1 and E2. This is measured, experimentally measures, okay, top and bottom surface at a distance of 0.5 meter from the tip. Okay. The eccentricity in loading E is. So we have to find this formula. What is the eccentricity in loading? Once we apply 10 kilonewton axial load. So there is some gap at there, P and E. So we have to find the E value. So normal stress sigma n equal to P by A. Bending strain is sigma m by AQ. Okay. 6m by AQ. So m is equal to PE here. So finally bending stress is equal to 60E megapascal. Okay. Stress at top is equal to sigma n plus sigma b. We have to add normal stress, bending stress. Normal stress is given, bending stress we just find 60E. Then we got this one. Strain is equal to sigma 1 by E. Sigma 1 we just found this one. E. Stress at down. This is for at top. For down again we will find sigma n minus sigma b, and this one. The strain measured by the two strain gauges are given. Compared, we just divide E1 by sigma equal to E2 by sigma 2, and then just equate, then finally we will get E equal to 1 mm. Okay. Actually here is mentioned bending stress, right? Sigma m by AQ. So here you can see stress is equal to, okay, m by I. So once we solve this 2, we will get m y by I, we will get AQ by 6. Okay, so that is y 6m by AQ for bending stress. Answer is equal to 1 mm. Okay. This is a square cross sectional area. Okay. It means I is equal to B dq by 12. It means A4 by 12. Y is equal to A by 2 half. That is, so y by I is equal to, AQ by 6. Question number 61 is very easy. This is total length is given 2b equal to 20 mm, thickness 0.6 mm. Okay. The second moment of area about a horizontal axis. So this is actually B, because this is total is 2b, here is mentioned, right? 2b, so half is B. And we have this K from here. Okay, K is equal to B, this is B, and the half of T is T by 2, so B plus T by 2. Second moment of area about x-axis is B dq by 12, and then because there are two flanges, wave is there, so we have this formula. Okay, and according to this formula we just put the value, like we mentioned K value here, and then that all values b, t. Okay, remember 2b is equal to given 20, so b is equal to 10. Okay, ix equal to, we will get 2947 mm4. So I want to show you from where I got this formula. Okay, so this is the website AMES web, and we just, if you google it, second moment of inertia, second moment of area, AMESWEB, so you will get this link. And then see for I section. Okay, for this I section, what is given in this same, right, I section, we have formula Ix equal to this formula, and this formula is same as this formula. Okay, this formula. Okay, so it is given for Ixx, horizontal axis passing through the centroid is about a horizontal axis. Okay, if it would ask for vertical axis, so we should apply this formula Iyy. So this is for I section, this is for O section. The formula is given, area moment of inertia, this is rectangle. Okay, this is a hollow rectangle, this is complete rectangle, this is C channel, and all formula is given. T sections are there, hollow circle are there, round bar area moment of inertia there, L section moment of inertia area formulas are given. So many different kinds of sections are there, and their formula is solved already here. Okay, and this is the calculator. Actually, once you have beam and then you mention some all formulas, you will get finally here answers for Ixx and Iyy. Anyway, for this question the answer is given, the final answer is 2947 mm4. For question number 62, a damper with damping coefficient C is attached to a mass of 5 kg and a spring of stiffness 5 kN per meter. The system undergoes under damped oscillation if the ratio of the third amplitude to the fourth amplitude, remember this is third to fourth amplitude is given, is 1.5. The value of C is third amplitude to fourth amplitude is 1.5. Delta is equal to ln of A by A3 by A4. This is the formula. Okay, this is called xi. 2 pi xi divided by under root 1 minus xi square. A3 by A4 1.5 mentions 2 pi xi under root 1 minus xi square. Finally we'll get xi value. Okay, now damping coefficient formula is 2 xi omega n into m mass, or either we can write this formula or this formula, it is same. Okay, because we know that omega equal to under root mk by k, right? So C is equal to 2 under root 5 into 5000, this one. Finally damping coefficient we can get C is equal to 20.4 Newton second per meter. Question number 63. A uniform rigid prismatic bar of total mass m is suspended from a ceiling by two identical springs as shown in figure. Let omega 1 and omega 2 be the natural frequencies of mode 1 and mode 2 respectively. The value of omega 2 by omega 1 is applying Newton's law of vertical motion. So for that I want to explain you from the check questions. One of the person explains very well, solve these questions. So this is the free body diagram and mentions about everything, all values are there. Okay, and there are two types of motions take place here. Rotation of the bar about its center of mass, and second is vertical translational vibration of the bar, where the total mass is given, total length is given, spring constant is given, then Newton's law of vertical motion is applying, and then finally you will get mx double dot plus 2kx equal to 0. Okay, then applying Newton's second law for rotation about center of gravity, you will get this one finally. And as we know, the moment of inertia ml square by 12, and once we put j value you will get this. For the harmonic equations, finally once we put harmonic x value, okay, you will get this one finally. And equation 4 and 5 in amplitude determinant form, you have to mention like this in matrix forms, and finally solve for omega square. So for omega square, you have, once we solve this quadratic equation, you will get omega under root 6k by m and or under root 2k by m. Finally omega 2 by omega 1 you will get root 3 value. So omega 2 by omega 1 is equal to 1.732 is the answer. Okay, the question is little complicated, I mentioned also same almost, so little complicated, but once you understand how to draw the free body diagram and mentions everything, it is easy to solve this formula. Okay, from the question number 64, an ideal ramjet is to operate with exhaust gases optimally expanded to ambient pressure at an altitude where temperature is given. The exhaust speed at the nozzle exit is to 1200 meter per second at temperature of 1100 Kelvin. Gamma value is there for air and for exhaust. It means for inlet and for outlet. Cruise speed of this ramjet is. So V2, T2, M2 represent exhaust. Ideal ramjet, for ideal ramjet engine, M1 is equal to M2. For inlet, these values are given. So for M1, so once we find the M2, that is M1 equal to M2, so M1 is equal to 1.8519. From that we can find V1 value. So V1 inlet velocity is 551 around meter per second, because it is showing cruise speed in the ramjet round off to the nearest integer, so it would be 551 meter per second. And this is the last questions. A multi-stage axial compressor takes in air at 1 atm 300 Kelvin and compresses it to a minimum of 5 atm. The mean blade speed is given, work coefficient is given for each stage, Cp is given. Again, if the compression is isentropic, the number of stages, so we have to find n value. So from the isentropic relation we can find T2 value, T2 equal to T1 P2 by P1 to the power gamma minus 1 by gamma 1. So T2 value is this one. Work coefficient formula is given, value is given, so we know the formula delta H by nu square. So delta H by u square by psi, delta H change in enthalpy, we can mention Cp into delta T. So n equal to Cp value is given, T2 value we just found, T1 value is given 300, u value is given 245 that is square, and size work coefficient also be given. So finally you will get around 5 point something nearest to 6. You will see here is mentions round up to the next higher integer. So if you will even get 5.2, 5.3, so we should mention next high integer, that is 6. Okay, so number of iterations required is 6. Okay, so this all about the GATE Aerospace 2022 solutions. Maybe I mentions everything here, and that solutions are different from your solution. Okay, many of the question you can solve easy, very easy. Okay, and here you can find the difficulties. Most of the question maybe you may not understand what I solve here, what I explain. Most of the question I didn't explain very deeply. So I assume that you have good knowledge. I just solve these questions, okay, so that you will have the little knowledge about how to solve these questions. Anyway, you have to practice more. Basics must be strong, okay, and you must know all trigonometric relations, geometric relations, how to change units, everything, and it would be very easy. You have to do every time practice while you preparing for GATE exam. All the best for your GATE preparation.